Okay, welcome. I know that I promised you that the next videos would be on trigonometry, but I was wrong because I had a misunderstood what the schedule was going to be, or what the schedule is, but it's all right, not a big deal, except for I made a broken promise, but that's okay. We'll eventually get to trigonometry, but we're going to talk first about limits. We're going to get into chapter 10 a little bit. So let me just give you an idea of what our goal is here. Okay. Now, so our goal is to make sense of the instantaneous rate of change. Okay. We can write it as the limit as b approaches a, f of b minus f of a divided by b minus a. Okay, and what this is that we imagine that we have some function. Okay, maybe doing some crazy thing here. Okay. We take A being here, B being here, and we could take the line that connects them, connects these 2 points on the graph. Okay, and we want to try to understand what's going on as A and B get closer together. Okay, and this gives us something called the tangent line. Okay, so this is basically the sort of genesis of calculus. Okay, so if you're taking Calc 1 in the fall, this is, or business calc or life science calc, this is what you're going to start learning about. Okay. All right. So what we're going to do, we're going to start looking at a couple problems to see. We're not going to worry about the difference quotient just yet. We're going to look just at the idea of this idea of limit. Okay. So let's start. We're going to take 10.1 problem 12. Okay, and that tells us, that asks us to take, hold on just a second here, 10.1 problem 12, it asks us to take the limit as x approaches -1, okay, of x squared plus 2 by taking a table of values. Okay, so it actually even gives us the x coordinates. So it even starts us out with a table. Okay, let me help you with that. So we have x, f of x, we get -1.1, -1.01, -1.001. We also get here, this is going to be our limit. They have this sign going in the book. -0.999, -0.99, -0.9. Okay, so I'm going to get myself a calculator here. and I'm going to start plugging in values. Okay, so I'm going to take 1.1 negative squared plus 2. Okay, and so in this first one, I get 3.21. 1.01 negative squared plus 2, I get 3.021. 1.001 negative squared plus 2, I get 3.002001. Ooh, running out of space. Okay, let's go from the other side. 0.999 negative squared plus 2, 2.998001. I'm just plugging it into the calculator. So I'm just plugging whatever this number is, I'm squaring it and adding 2. So I get 2.9801. And then negative 0.9, I get 2.81. Okay, so what I'm asked, now we're asked to do a little bit of sort of analysis, a little bit of thinking, and we think, well, it's reasonable to assume that if we put negative 1 in, we would get 3 back. In this case, I mean, we can actually literally do it, right? So we're going to put in 3 as saying as, and so what we're saying here is as x gets closer to negative 1, x squared plus 2 gets closer to 3. Okay, and what we're doing here is we're providing a language to do that's actually more flexible than our usual functional notation. Okay, so let's do another one. Let's do 20. Here, it gives us the directions to make a table. To find each limit. Okay, and the limit is the limit as x approaches negative 1, x minus 1 over 3x. Okay, so this time we're going to do the same sort of thing, except for this time we're not given the x values. In the first problem, we were given these x values. This time we have to make them up. Still not a big deal. We can actually use pretty much a very similar table, which I will do. So much so that I'm going to copy it. And erase my y values. Okay, so now we're going to do the same thing, but now we're going to use this expression. Okay, so negative 1.1 minus 1 divided by 3 divided by 1.1 negative. So I get, I'm going to need to zoom in a little bit here. Well, 0.636. Okay. And the 3.6 is going to be repeating. Okay. Doing it again for 1.01, I get 0.66336633. So I'm guessing that this is going to be our pattern because the next number is 7. But I'll just leave it as my calculator gave it. Okay. I'm do the same thing for negative 1.001. 0.666333666. Okay, so I'm guessing it's going to be that pattern as well. Okay, let me make those a little bit bigger. Okay, now let's look at negative 0.999. Try that again. I think I made a mistake. Made a mistake again. There we go. And I get 0.667. With 0.00334. Not really that important because those are going to be. Let's just do it for completeness. Do the same thing with negative 0.99. 0.67, 0.03367. Finally, with 0.9 negative, 0.70. Now, one thing that we might notice is that if we actually plugged in -1, what are we going to get? That's really not what we're doing here, but it is helpful in a lot of situations. So if we plug in -1, we're going to get -2 over -3, which is 2/3. Okay, which is actually, if you think about it, 2/3 is 0.67 or 66 repeating. Okay, which looks to be like very similar to the limit here. Okay, so there is a relationship between the two. The difference is, or the key point is that we may not always be able to plug in the number, but we can take the limit more often. So there are more situations where we can take the limit than where we can just plug in the number. Okay, so that's one of the key things, is that even when we can't just plug in the number to find a value, we can still take a limit. Okay? All right, I'll see you all in the next video.